Okay, so at this point you should be pretty good at balancing equations. Just keep in mind some of the tricks you've learned. What we're going to do is we're going to add to it. We're going to add to some of the two balancing equations, one of the skills that you developed earlier in this chapter, at the beginning of chapter 5. So we're going to translate word equations into chemical equations. So you're going to have to combine your knowledge of writing formulas with your knowledge of balancing equations. So the number one thing you want to do is go kind of in order. Balancing is the very last thing you do. Okay, so I know you're anxious to do it because it's easy to do when you understand it. But take your time, okay? When you're writing the chemical equations, the first thing you should do is write out the elements for the symbol, or the symbols for the elements, or the formulas for the compounds. And you want to use correct nomenclature rules for determining formulas. And you also want to watch out for the diatomic elements. Let's refresh your memory on those. At BrINCOHONF. That means if you see the word bromine, it means Br2. Or you see the name hydrogen as one of the reactants or products, it's H2. Okay, that means they're diatomic. They exist doubled. So first thing is you write the symbols and the formulas. You're going to use a plus sign to separate the reactants from each other. So keywords are reacts with. And a plus sign to separate the products from each other. And then you're going to separate the reactants from the products with an arrow. And then you balance as usual by using coefficients. Do not change the subscripts. You did that in step number 1. You came up with the subscripts. Don't mess with them. Okay? Don't change them. Change the coefficients. Okay? Because this is the hardest thing. You have to get the formulas correct. Okay? Big star, big exclamation points, because that determines your correct formulas. And once you have the correct formulas, then you can balance it. It is entirely possible that you can go through this without the correct formulas and try to balance it, and you can spend a very long time balancing. So formulas are most important. So, for example, here's a practice problem. Aluminum. Well, aluminum I know is an element, so I'm going to just write Al. It's not one of my diatomics, so I'm just going to write it, boom, Al. The word reacts with means plus. Now, magnesium oxide, I'm going to go back to my rules for formula writing and look up magnesium and look up oxygen. And if I look at the top of the periodic table, magnesium's 2 and oxygen's -2. When I drop and swap, I end up with Mg2O2. But this is an ionic substance, which means you can and should reduce it, if possible. So those are my reactants. And then it says to form. To form means arrow. It says magnesium. Well, magnesium is an element. It's not one of my diatomics. Plus aluminum oxide. So and turns into a plus sign. Aluminum oxide, again, I'm going to use my nomenclature rules. Aluminum is 3. Oxygen is -2. When I drop and swap, I end up with Al2O3. Okay, so getting the formulas is the longest part of this. And it is the most important part. Because if you didn't have them right, it makes it awfully hard to balance. Now that all my formulas are correct, my arrows, my plus signs, I have 1 Al on the left, 2 on the right. I'm going to put a 2 here. I have 1 Mg on the left, 1 Mg on the right. All is good. I have 1 O on the left, 3 on the right. So I'm going to put a 3 here because that 3 will distribute to the Mg into the O. But of course that gives me 3 Mgs. And that is my balanced equation with correct formulas. Right there. Notice I don't have any of these pluses and minuses part of it. I have dropped and swapped before I put them in to the formulas and into the equation. All right. Go ahead. See if you can set this one up. Okay, remember the biggest thing you want to focus on is formulas. So cobalt, chloride, and again, CO, this 2 is referring to the charge. Chloride, I look it up. When I drop and swap, I end up with that. Reacts with means plus. Sodium phosphate. Sodium, I look it up. Phosphate, I look it up. I drop and swap. And I end up with that. Okay? So I've got my reactants. Formulas correct based on the charges. To form cobalt-2 phosphate. So I'm going to do that one down here at the bottom so I have a little space to work with. Cobalt-2. Phosphate is PO4, -3. When I drop and swap, I end up with CO3, PO4, 2 plus, and a sodium chloride, Na plus, Cl1 minus. So I'm going to write that underneath. Sorry, I didn't have enough space. I don't judge well when it comes to that. All right, so now I need to balance this. All my formulas are correct. I have dropped and swapped. I've done the hard part. So now I need to do the easy part. There is 1 CO, 3 CO. So I'm going to put a 3 here. 3 times 2, remember this distributes. 3 times 2 is 6 CLs. So I'm going to put a 6 all the way over here by my CLs because that will distribute to the CL. It also distributes to the Na. Since I have 6 NAs, I need to put a 2 here because 2 times 3 is 6. And then now, with the phosphorus and the oxygen, I have 2 times the phosphorus is 2. Remember, this also distributes, so 2 times phosphorus. And I have 2 times 4 for the oxygen, and I have 2 times 4 for the oxygen. So this is the balanced equation with correct formulas. Okay? Go ahead and see if you can do this one. Okay? Be real careful. You want to pay attention to whether it's a diatomic element or not. All right, so for potassium iodide is K1 plus. Iodide is I1 minus, so that gives me Ki. Reacts with means plus. Fluorine is one of my diatomic elements. That means it is written as F2. And then arrow to produce. Potassium fluoride is K1 plus and F1 minus. It gets that charge when it becomes part of a compound. As an element, it's always a 2. But it gets that charge when it's part of a compound. Kf plus iodine. Iodine is another one of my diatomic elements. So as iodine, it exists as I2. When it's part of iodide, it's drop and swap with the -1. All right, balancing this is pretty simple. 2 I's, so put a 2 here. Of course, that doubles your K's. Put a 2 here, doubles your K's, doubles your fluorines. Everything is good. All right, now this one's a little trickier. Hydrochloric acid, you have to remember back to what is hydrochloric acid? Well, it comes from H1 plus, and hydro tells me it comes off the periodic table, so it's HCl, reacts with calcium carbonate. So calcium is 2, carbonate is CO3, it's a 3, 2 minus. When I drop and swap, there would be a 2 on each one of them, but I'm going to reduce that. I'm going to get rid of that 2, and I'm going to erase it right now. Reduce it down to 1 to 1. Oops, go back. And it's going to produce calcium chloride, so I'm going to do that down here because I'm running out of room. Calcium chloride, drop and swap, CaCl2. Water, I would expect you to know, is H2O. And then carbon dioxide, following our rules for carbon dioxide, is CO2. No dropping and swapping. Di means you just write it down, 2. Okay, so those are my correct formulas. Now I'm going to balance this one. I see 1H and I see 2 H's. If I wanted to skip that, that would be fine. I'm going to go to Cl. 1 Cl, 2 Cl's. I'm going to put a 2 here, which now gives me 2 H's. I have 1 Ca on the left, 1 Ca on the right, 1 C on the left, 1 C on the right. I have a total of 3 oxygens in my calcium carbonate. And I have 1 in water and 2 in carbon dioxide. So if you add this all up, it is completely balanced right now. Okay? This is why it's really important to get those formulas right. Okay? All right. Let's go ahead and do this one. Phosphorus, that's one of my elements. P, nothing special about it, just P. Reacts with oxygen. Remember, oxygen is one of my diatomics, so it's O2 to form diphosphorus pentoxide. When you see those prefixes, remember, you don't drop and swap. All you do is write them down. 2 phosphorus, 5 oxygens. So put a 2 here. That gives me 2 P's and 2 P's. I have 2 O's and 5 O's. And if you remember, one of the tricks that we talked about when we were doing balancing is if you have an odd number, sometimes it helps to double it, which gives me now 10, turns this into a 4. It's 2 times 2. 2 times 5 is 10. That means this needs to be a 5. Okay, so just kind of pay attention to your balancing rules, but the most important thing is get the formulas right the first time.